here we are applying the slope, midpoint, and length formulas. So you have all of these formula in your toolbox, and now we're going to be solving some word problems using them. So what we want to take on first is just the 4 steps of problem solving. 4 steps of problem solving. The first, you're going to read that problem carefully and understand it. You need to understand the problem. Understand the problem. 2, once you understand the problem, you need to choose a strategy. Choose a strategy. Now, there are lots of strategies that you can choose, such as, guess and check. But typically, we're going to be using algebra. We're going to figure out what algebra tools we have and see what we need to apply, okay? So then we're going to carry out strategy. Part of this choosing a strategy and carrying out a strategy could be what we have been doing in previous lessons, like find out what you need to do, and then what you need to do in order to do that, and what you need in order to do that, and what you need in order to do that, and then work back up to the top. Carry out the strategy, and then 4 is reflect. Essentially, all that means is go back to the word problem, see if what you did is correct, see if you actually answered the question that is being asked, okay? The list of formula that we are going to be using, so this is a good place to look back to. We have the standard equation for a line in slope-intercept form. That's y equals mx plus b. You have an equation or a formula for slope, which is called m lowercase. You can see it comes right out of our slope-intercept form, and that is the difference in y over the difference in x. That's the slope, right? Rise over run. If you have a hard time remembering that, just plug it in there. Rise over run. We've also learned the midpoint formula. The midpoint of any line segment, the coordinates are, you take the average of the x coordinates and the average of the y coordinates. Now, for memorization purposes, be careful. In the slope formula, you have y2 minus y1 and x2 minus x1. In the midpoint formula, you're finding an average. Okay, you're finding the middle. So you need to add those and divide by 2. You need to add the quantities of your x coordinates and divide by 2 to find the middle. Same with your y coordinates. Add them, divide by 2. Another formula that we have is the length formula. The length formula, and that is derived from a squared plus b squared equals c squared. So that's helpful. But then we want to call it, you can call it the length or the distance formula. I'm going to use a d here, but it could be an L out front, would mean the same thing. And if we work through that Pythagorean theorem, a squared plus b squared equals c squared, which we did in a previous lesson, you end up with x2 minus x1. That is the distance traveled along the horizontal axis from one point to the next. We square that. We add it to y2 minus y1, which is the distance traveled along the vertical axis to get from the one point to the next. And according to the Pythagorean theorem, we square each of those, add them up, and then we take the square root, and we'll get the distance. We'll get the hypotenuse, okay? So you could actually, if you wanted to help yourself out, you could put hype there just to remind you that what you're really getting is the hypotenuse of a right angle triangle. So any problem that you get into, you're going from point A to point B, all you need to do is think, okay, I can make this a right triangle. I know this leg, and if I find out that leg, then I can find out that leg. That's not a leg. I can find out the hypotenuse. Okay, there's the tools that you're going to use, the 4 steps of problem solving, and all the formula that we need moving forward. So heading to example 1. In example 1, we're going to find the shortest route from a point to a road or from a point to another point. Let's see what we're going for. A ranger cabin is going to be built in a flat wooded area. It's helpful that they tell you it's flat, so there's no hills to walk over necessarily. It's not faster to go around a hill. You're just going to go straight line. A ranger cabin is to be built in a flat wooded area near the straight road that connects the 2 campgrounds in a park. A new side road is going to connect the cabin to the campground road. So you can see the campground road AB in your picture, and you can see the new site of the cabin down at the bottom, cabin site R at 6.1.5. And what do we need to do? We need to get the shortest distance from the cabin site to that road. So if you have a straight edge or a ruler, go ahead and just play around with that picture. Put your ruler on the cabin site and see what it looks like if you draw the shortest distance to the road. What does that line look like? Okay, hopefully you figured out a line a little bit like this blue line that I've drawn from C to the campground road. And what do we notice? It hits that line at a right angle. The shortest distance between a point and a line will always be a perpendicular line. Okay? Always. So now we have a big hint because we know the coordinates for A, we know the coordinates for B, and if we know that these are perpendicular, what does that tell us about the equation of those lines? What part? They opposite, yeah, opposite-ish. What parts do we know about then? What makes the line perpendicular to another line? Opposite reciprocal slope. Okay? So if we know the slope of AB, we also know the slope of C line, the line that extends from C to AB, okay? So let's think this through. We're going to, step 1, use A and B, those points, to get MAB, M subscript AB. That means the slope of AB. Then, slope of side road is opposite reciprocal. Then, find intersection of side road and AB. I'll talk about this in a second as we go through. After that, once we have the intersection, so the goal is, right, the goal is to find the distance from C to the side road. So it's helpful to know the slope of this because we're going to need an equation of a line in order to find the intersection, in order to find point D where they intersect. And if we can find point D, then we can find the distance from D to C using our length formula. So we're going to find the intersection of the side road and AB. That's going to happen at D. Then we can find length of CD, okay? You have a little note there. It says use your space carefully. This one is pretty long. So we're going to work through this step by step. So the first thing that we're going to do, we're going to calculate the slope of AB using the coordinates of AB, okay? And as you're going through long assignments like this, long challenging problems, you want to note what you're doing, okay? Slope of AB. You always want to do that. If you get really good at it and you know where you're going, then this is probably enough. Slope of AB. And then we're applying our slope formula, which for the sake of notes, I'm going to write every single time. We've got y2 minus y1 over x2 minus x1. I know these coordinates, okay? So it doesn't matter which point you use as point 1 and point 2, as long as you're consistent. I'm going to go 2 minus, sorry, that's my x values, so that's going to go on the bottom. But the y values then, 8.5 minus 4.5 over 2 minus 10. The numerator reduces to 4. The denominator is negative 8. That's a slope of negative 1/2. Okay, if we know the slope of the red line, AB, then we also now know the slope of the side road. Slope of side road. Okay, M, and I'll just use, I guess, SR down here for side road for now. Actually, I know it's going to be CD, so why don't I just call it CD right away? The slope of CD is going to be the opposite reciprocal of negative 1/2. So opposite means instead of a negative, I have a positive. Reciprocal means flip your fraction. 2 over 1, same as 2. So the slope of the side road is positive 2. All right. Well, now this part is a bit tricky, okay? So this part is done, but now in order to find this point of intersection, we actually need an equation for AB and an equation for CD. There's a couple of different ways to do this, okay? Step 3, this isn't really step 3 according to here, but find intersection. In order to do that, we need to find equations of lines. So over here, let's do the line AB. We know the slope, negative 1/2, and we know 2 points on the line. So we have y equals negative 1/2 x plus b. We don't know the y-intercept. It's not good enough to just look at the map and think, oh, I can find the y-intercept. What you have to do, which we've done before, sub in coordinates for x and y that satisfy the equation. Well, you know that this red line goes through A and it goes through B. So let's use those points, okay? In this case, we'll use point A, where y is 8.5, x is 2, and now we can solve for B. 1/2 times 2 is 1, and it's a negative. I have B by it on the right, and it's positive, so that's good. So I'll just add 1 to both sides. I get B equals 9.5. So for the line AB, the equation of that line is y equals negative 1/2 x plus 9.5. We're going to do the same thing for the line CD. That's the new road. An equation for that line in slope-intercept form, we know the slope down here is 2. So we've got y equals 2x plus b. Now we need to solve for b by subbing in a point that we know. Now you say, well, I don't know d. No, that's what we're trying to find. But you do know the point where the new cabin is going to be. Okay, if you look on your diagram, that's at 6.0, 1.5. So wherever we see a y, we sub in 1.5. X is 6. Now the only variable left is b, so we can solve. 1.5 equals 12 plus b. Subtract 12 from both sides. Subtract 12 from both sides. You end up with b equals negative 10.5, which gives you an equation for CD of y equals 2x minus 10.5. So you can see how we're just taking all the stuff that we've learned already and putting it into a bigger problem. Now we have enough information. We have an equation for line AB and we have an equation for CD. So we can find that point of intersection, and we remember that the point of intersection is where the x and y from one equation are equal to the x and y from another equation. That's the only place where they will share an x and y. Therefore, that's the point where they both go through. It's an x and y that satisfies both equations, okay? So I'm going to do that now. We'll write a little step 4. Find point of intersection. Now to do that, I can choose, again, between substitution or elimination. In this case, I'm going to use substitution. Okay, could use elimination because the y's are lined up, the x's would line up, and the 1's would line up. I'm going to use substitution because I know that y is equal to this and y is equal to that. So all I have to do is set the right side of my first equation, negative 1/2 x plus 9.5, equal to the right side of my second equation, 2x minus 10.5. Both of these expressions are equal to y. So if y equals y, then this expression must equal that expression. Now I'm just going to use basic algebra. I'm going to move things back and forth by addition and subtraction. I notice that it'll be easier for me if I add half of an x to both sides. Okay, if I add half of an x to both sides, I'm going to show 2 steps at once. Add half an x to both sides, and I'm going to add 10.5 to both sides. Okay, that will give my x's all on the right here. I'll be left with 2.5x. And on the left, I have 9.5 plus 10.5, that's 20. Now I just divide both sides by 2.5. We're into familiar territory now. 20 divided by 2.5 in the calculator. Click, 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 click. It's 8.0. Now, think back. What are we actually finding out? This is the x coordinate of our point of intersection. Okay, so if we look up here on D, we just found the x coordinate is 8. All right. Now we need to use that x coordinate to find the y coordinate. We can do that by subbing in to either one of these equations. Okay, I might look at this one because it's got a whole number here and it's positive. Might be easier to work with, but it shouldn't matter. You should get the exact same answer no matter what. So I'm going to go y equals 2x, but I know x is 8, so 2 times 8 minus 10.5. It gives me 16 minus 10.5, which is 5.5. So now I know that the y coordinate of D is 5.5. Okay? And we're on our last step. Now we know the intersection. So we have a point C and we have a point D. We have a point C and we have a point D. So now we're going to find length of CD. How do we do that? We apply our length formula. So our length formula or our distance formula, we can rewrite it. It's x1 minus x2, or you can do x2 minus x1 plus y1 minus y2, as long as you're consistent. Plug in the coordinates for C and D underneath the radical inside these groups. We're going from D to C or from C to D. Again, it doesn't really matter what you do. So I'm going to use as my y, my difference in y, we're going from 8 to 6. Sorry, that's the difference in x's, 8 to 6. And then the difference in y's, we're going from 5.5 to 1.5, so 5.5 minus 1.5. And according to Pythagorean Theorem, we're squaring both of those and then adding them and then taking the square root. This is where your calculator comes in handy. It can do a lot of this all in one step. If you actually knew how to punch it in proper, you could do this whole thing in one step. but I'm going to do it in a couple steps just so you can see what happens. First bracket reduces to 2 squared. Next bracket reduces to 4 squared. Underneath the radical still you have 2 squared is 4, 4 squared is 16. Add those up, you get 20. And the square root of 20 is approximately 4.5. And this is being measured in units. And then we have a scale on our map that actually allows us to decide how far it is. Each unit on the map grid represents 500 meters. So this is units. And each unit represents 500 meters. So all you'd have to do is take that answer, multiply it by 500 meters. And what would you get? You get 2,250 meters. And you could round that to 2.3 kilometers. Quick run through of what we did. We needed the length of CD. In order to get the length of CD, we needed point D. In order to get point D, we needed to find the point of intersection of these two lines. In order to do that, we needed an equation for each of those lines. In order to do that, we needed the slope and y-intercept of each of those lines. So that's where we started. We found the slope of AB, then we found the slope of CD, then we found the y-intercept of AB, then we found the y-intercept of CD. Now we had two equations. If you have two equations, you can use substitution elimination to find the point of intersection. Once we had the point of intersection, which is D, we now had coordinates for the point C and coordinates for the point D, in which case we could apply our length formula. Because it's on a grid that was measured in units, we still had to convert into an actual length of 2.3 kilometers using the information given from the problem. Example number 2 says determine a geometric property algebraically. So when it's saying a geometric property, it means you're dealing with a shape. What shape are you dealing with? In this case, a triangle ABC. And we're going to learn about a property of them, and we're going to do that using algebra. So we're given the 3 vertices of the triangle, and we want to determine whether ABC is a right triangle. What would make it a right triangle? What would make it a right triangle? Having a 90-degree angle. How do I determine that? More words for 90 degree.
A right angle. But
What will it have? If triangle ABC is a right triangle, comma, it will have better algebraically. I can't determine a 90-degree angle algebraically. What can you determine?
Pythagorean theorem.
It would, if it satisfies the Pythagorean theorem. So you could find that's not a bad way to go. Actually, we're not going to do that way because it's not the best way to go. But if a squared plus b squared does equal c squared, then that would be a right angle triangle. Okay, so if you found the distance from here to here, and the distance from here to here, and the distance from here to here, and then you plug that all in to the Pythagorean theorem, and you did left side, right side, and it came out even at the bottom, that would verify that this is a right angle triangle, because the Pythagorean theorem will only work in a right angle triangle. So that's actually really good thinking. It's not what we're going to do. Let's think of another way that we could do it. What is true about a right angle? Two lines that intersect at a right angle. Two lines that are perpendicular. What about those lines is useful to us?
They'll have the opposite slopes.
Close. The slopes of perpendicular lines will be opposite reciprocals. Okay? So now all we need to do is find the slope of this line, the slope of this line, the slope of this line, and if any two of them are opposite reciprocals, we know we have a right angle triangle. And of course, because we have a picture, we're going to do the two first that we think are probably going to be. But never trust your pictures. You might need to try all 3 of them. Okay? How do you know?
It could possibly
could possibly be. Okay, so here we go. Please write this down.
Have the little square.
If they're not going to tell you that it is, you're going to determine whether or not it is. So here we go. If triangle ABC is a right triangle, it will have two lines with slopes that are opposite reciprocals. I'm going to just briefly give you the explanation of opposite reciprocal, okay? So far all I've taught you is this. If I say M1 equals, let's say negative, this is just an example, okay? You don't need to write this necessarily. Then M2, this is from our last problem, right, is the opposite, so it'll be not negative. And it's a reciprocal, it means you flip the fraction, positive 2. Now, look at what that actually means. M1 times M2. What is that? Well, you'd have negative 1/2 times 2. So you'd have negative 1. Opposite reciprocals are slopes, or just fractions really, just values, that when you multiply them together, the product is negative 1. Okay? So that's what we're testing. We're trying to find out if any of the slopes, if we take M1 times M2, do we get negative 1? That's what we're looking for. Okay? So here we go. Slope formula. We have 3 lines. My diagram is not accurate, so this was just for the sake of explanation. You have a diagram right in front of you. Which lines would you like to find the slope of first? Which ones do you think are right angles? Which lines do you think make the right angle if there was going to be? Okay, well, that's the same line. AC and CA.
No, I said B,
okay.
C, and CA.
Okay, good. So we've got the slope of AC and the slope of BC. We'll do those ones first. If we need to, we'll do the slope of AB. And that would be all 3 lines. Okay? So, what's our slope formula? Well, since I'm going to do this 3 times in a row, I probably just put my slope formula at the top. y2 minus y1 over x2 minus x1. And if I really need to organize my stuff, I might just tell myself, oh, it's in the problem. You know that A is 5, 5, B is negative 3, negative 1, and C is 1, negative 3. You're going to make sure you copy all those coordinates properly every single time. And now we go for it. AC. Does it matter which point I do first? Which point I call point 1 and which point I call point 2? Doesn't matter, as long as I'm consistent in the numerator and the denominator. Okay, I'll do this one, and you do the slope of BC, and then we'll see if we got the same, see if we got opposite reciprocals. Happy? So here's your test. 2, the reciprocal of 2 is 1/2, and opposite of a positive is a negative. So these are opposite reciprocals. The proper way to check would be to say, since the slope of AC times the slope of BC equals negative 1, triangle ABC is a right triangle. Okay, we didn't even need to do the slope of AB because we found our two that are opposite reciprocals, that when we multiply them together, we get a product of -1. Therefore, that makes a right angle. If there's a right angle, it's a right triangle. I'll also quickly show how you could do it by using Pythagorean Theorem. Like we described earlier, if we can find our legs and we can say a squared plus b squared equals c squared and it checks out, then we know it's a right angle triangle. So now all we need to do is find the distance, the length of each line. So we would be using the length formula for AB. We'd be finding, and I'll just write it out once, but basically the length formula is x2 minus x1 squared plus y2 minus y1 squared. I won't write it out for all of them, but we would do the same for AC, and we would do the same for BC. Okay, this is a multi-step kind of situation. When you do it with AB, you end up with the square root of 100, which reduces to 10. The length of AC is the square root of 80. We're not going to reduce that to, we're not going to round that down in our calculator because it's not a square number, so we'll just leave it like that. And for BC, we have the square root of 20. Okay? So now we need to apply Pythagorean theorem. Now we need to apply Pythagorean theorem. A Pythagorean theorem says, and I'll just say, we assume that the longest side is going to be our hypotenuse, right? Square root of 100 is longer than these guys. And you can even erase that 10. You don't need to reduce it. Basically what we're saying is in our Pythagorean theorem, the left side is the square root of 100 squared. And the right side is the square root of 80 squared plus the square root of 20 squared. Okay, that's basically just coming straight from this. A squared, well, I'll write it the way I did it. I did the hypotenuse on the left, c squared. And on the right, I did a squared plus b squared. You will need to know how to do this. Well, what is a number? If I take a number and I square root it and then square it, what happens to it? It's just the number itself. I'm doing inverse operations. I'm doing something and then doing the opposite. It's like adding 5 and then taking away 5. What do you have? Same number. Okay? So 100, the square root of that is 10, and 10 squared is 100. On the right side, well, 80, square root of 80 squared is just 80. And the square root of 20 squared is just 20. So I do indeed get that left side equals right side. If this works out, if it fits the Pythagorean theorem, then you've also shown that it is a right angle triangle. Okay, algebra is helpful. There's more than one way to solve. Example 3 has you having a median to a hypotenuse. So a median to a hypotenuse. It's going to go from a point to the midpoint of the opposite side, which is going to be the hypotenuse. So all we need to do is show that the median from the right angle of the triangle is half as long as the hypotenuse. Okay, are you understanding this? We're getting into some geometric proofs here. I'm going to try to kind of sketch out the triangle that you guys have. It's a bit like that and like that. Okay, we found out that this is a right triangle. Okay, we know A, B, and C. And I'm going to describe what we're doing here. We're going to take the median from the right angle. So we're going from C, pay attention, to the midpoint of AB. Okay, so we need to find the midpoint of AB, and then we need to find the length of this line and the length of the hypotenuse and compare those lengths. And it should come out that MC is half the length of AB. Okay? All right, so here we go. We're going to find out the length of the hypotenuse and the length of the median. Now, we already have enough information to find the length of the hypotenuse, but we don't have enough information to find the length of CM. So what are we going to do? Well, we know this is the midpoint, so let's apply our midpoint formula. We're going to, 1, apply midpoint formula to find the coordinates of M. All right, what does that look like? MXY is equal to the average of our known X coordinates and Y coordinates. Fill in what we know. We know the coordinates of A are 5, 5. And we know the coordinates of B are -3, -1. 5 minus 3 is 2. 2 over 2 is 1. 5 minus 1 is 4. 4 over 2 is 2. So there's the coordinates of our midpoint. We can add that to our diagram. And now we can do two things. We can find the length of CM. So the distance, I'll just put a little note here, find length of CM and AB. We don't have to find AB because we already found it last example. Okay, we already did that. We found out that it's 10. So if CM is half of 10, then we know we did well. So here we go. The length formula, I'm going to rewrite it again. If you have it memorized, you don't need to rewrite it. Basically, it's the difference in your horizontal distance squared. Add that to the square of the difference in your vertical coordinates, and then square root the whole thing. The sum of those. Plug in what you know. Doesn't matter. I'm going from M to C. Doesn't matter what point I call 1 and what point I call 2, as long as I'm consistent. So I've got 1 minus the x coordinate of C, which is 1 also. And I'm going to add that to the difference in my y coordinates, 2, and the y coordinate of C is -3, so I've got 2 minus -3. My first bracket is 1 minus 1 is 0. Anything times 0 is 0, so that just disappears. Second part is 2 plus 3, which is 5. I'm going to square that. So I get 25, and the square root of 25 is back down to 5. And what do you notice? Since AB equals 5, and, sorry, not AB, AB equals 10, and MC equals 5, MC is half of AB. So what did we actually find out? Writing a statement, because this is what you have to actually remember. Therefore, the median from the hypotenuse, that's our line CM in our diagram, the median from the hypotenuse is half the length of the hypotenuse. That is a special relationship in a right triangle between the hypotenuse and the median from the hypotenuse. Okay, all we did was find the midpoint in order to get the length of the median, and we already had the length AB from a previous example. 5 is half of 10, therefore it checks out. Your practice problems indicated at the bottom of the page is from the worksheet on the next page in your notebook. Problems 3 through 9, 16, 17, and 20.